Functions are blocks of code which realize a particular task. Say we want to have a particular task, say task A done. To define the function, we use a keyword def. So we have def, we have the name of the function or the name of the task, and then we have the arguments, that is values which we pass into the function and which may modify the function's output. We have the two dots, and then we have return. So we return whatever value. So here we have arguments, and then here we have outputs. Now let's define a function which gives the sum and product of two integers. So we have int1 and int2, which are passed as arguments. And then here we simply return int1 times int2, comma int1 plus int2. We run this, and then we can call this function. So we could have sum, comma product. Now sum is a keyword, so we can have sum 1, comma product 1, which is equals sum product of two integers, say 2 and 3. We print out sum 1 and product 1. Running this, we have an error. We're told that this is not defined. Now let's look at this. That was because actually here we didn't put this plus. We will run this now. We have 6 and 5. We see that here we have the product, and here we instead have the sum, and that's because while returning here we put this as product and this as sum. So let's reverse this, and we should be having 5, 6. That tells us that the sum of these two numbers is 5 and their product is 6. So that's what this function actually does. We could actually rewrite this by saying the sum of numbers equals, say, int1 plus int2. We could also have product of numbers equals int1 times int2. And then here we simply return product of numbers, and here we have sum of numbers, sum of numbers. So we should have the same results. Now what if we make a call to this function while omitting one of this? If you omit one of this, you should have this error message saying that there is one missing positional argument, and that's because these two arguments must be given when making a call. So we could change this to, say, 80, and we have that. Now let's see how to define default arguments. Say we have a default argument here, say 23, and in this case we could put out 2. See what we have. We see that here we didn't actually put in this second argument. In this case, like now we've put this is giving us the sum and the product, which is 4, 4. But in the case where we don't put this, say we put just 20 like this, you see that what you actually have is the sum of 20 and 23 and the product of 20 and 23. And that's because this is a default argument, and with default arguments you mustn't pass in the argument when you're making a call to the function. Now if you have the default argument and then you have another argument, let's say int3, running this, you see that you already have an error, as a non-default argument cannot come after a default argument. So if you have this, you should have the int3 coming before, so you have your int3. Now running this is fine, but running this has a problem because there is this non-default argument int3 which hasn't been defined, or which hasn't been passed into the function when making the call. So we have to actually add that. Although in this case this int3 isn't doing any much work. Now let's define another function. Say we have def, we have print time, or let's say print name. We have this function print name, which takes in a name and age of a person. So we have this age. So let's take a default argument, say 70. That's it. We have return. Now, if you aren't returning any value, you could simply put return none. So with this, running this, you have no problem. And then you could make a call to this function. So here we could say print name of, let's consider the name to be Joseph, and that's all. You mustn't put the age, but if you have to put this age, you could select an age, say 23. You see that here you have this known. Now let's modify this, as this is meant to be an int. So run this again. Here we have known. Now we could also return this string, which is made of this too. So you could have a string made of name plus string of the age. So what we're doing here is we're converting this age into a string. So with this, you should have name, or you could have a string before this name. You could have my name is this, and here you add a plus, and then here you have I am of age this, and then you have this plus 2. So actually just concatenating this different strings. We have this first string, you have this next string, you have this next string, and you have the string. So we have this int which has been converted into a string. Now you should note that you could actually convert it into a string. Say a equals 6. You could have print string of a, and you have this as a string. You could also convert this string, or you could convert a string, say b equals 7, into an int. Here you could say c equals the int of b plus 3, and you could print out c. So you see that here you have 10. That's because this has been converted into an integer. Now coming back to this example, printing this out, we have my name is Joseph and I am of age 23. So let's modify this again. You could have my name is, after this you put this space, and there we go. So that's it. Now suppose we have a variable which adds up your age internally. So we have this variable adder, which is equals 40, such that you have adder plus age. So here you can have my name is Joseph and I am of age 63. So here your age has been added automatically. Let's try doing this without the string. You find that you have an error because you are adding up a string to an integer. So here we have this, and that's it. Now let's decide to create another variable out of this function. This variable is also called adder. So we have this adder variable which is 80, and we'll run this. We'll see that actually in this function, the adder we're considering is this adder. So if you have this, if you comment this, you actually have this adder which was defined out of the function used. So this is a global variable and this is a local variable. Local in the sense that it's used only within this function. So if you create another function, you try to use this function, or you try to use this variable, you wouldn't get access to this variable. Let's create another function simply. So we have print data, and we have my name is this, age this. We could maintain the same output. Now we're trying to use adder. Let's take away this adder and let's run this. So let's create this adder here, which is this local variable, and we'll try to use adder this way. For now there's no problem, but once we try to change this to print data, that's to make a call to this function. We have this. Oh, it seems to be working, but that's not right. Let's restart our kernel. Restarting the kernel, should be able to get an error here, and that's because the way this Jupyter notebook works is that once you had declared a variable adder initially here and put a number, say 80, this variable remains even when you remove it like this. So restarting will make us be sure that we don't have that variable in memory again. So let's run this, and we'll see that we actually have an error, which is what is expected because this is not defined. This is defined in this function, but not in this. So this is a local variable. Now we can define a global variable 80, and you see that now it works. So that's how we proceed with this local and global variables. Let's now look at functions in which the number of arguments we could pass as variable, unlike this functions we've seen so far in which the number of arguments are known. So let's take in this function, say laptop characteristics. The way this function works is it gets the name of the laptop, gets SSD memory, HDD memory, and then the RAM, and then simply prints out those characteristics. So right here we could have laptop characteristics. We have the name, say MacBook Pro. We pass in the SSD memory, say 128, HDD 1024, RAM 8. So we run that, and there we go. We have the name, the SSD memory, HDD memory, and then the RAM size. For now, our function has a fixed number of parameters. Now let's suppose that we want to pass in this, or we want to get this, where we have a GPU memory of say 4 gigabytes. So we'll run that. You see already that this takes 4 positional arguments, but 5 were given. So we have this error, which is normal. Now if we do this, if we say GPU memory and we run that, you see that works fine. We just need to come here and include this GPU memory. So here we have, or we could say dedicated GPU, and then we have the GPU right here, GPU memory. Run that. That's GPU, so let's take this off, and there we go. So that's what we get from that. But it turns out that not all laptops will even possess this dedicated GPU memory, and even some will not possess an SSD memory. And so instead of having to separately define another laptop characteristic method in which for the first we could consider all this, for the second we will say, for example, that in the case where we don't have the SSD memory, we'll have this. So yes, we could define this without SSD, and then this other one we'll define it without SSD and GPU. So we'll take this GPU off, we'll take the SSD off, and then this other one we could also say we'll define without just the GPU. So we'll leave the SSD and we'll take this GPU off. So you see that we cannot continue working like this, as this not only isn't efficient but it's also not scalable. So we'll simply take this off, and then we'll work with methods which have variable number of parameters. So in that case, instead of having all these parameters, what we'll simply do is we would have an asterisk added before a certain params, or say arguments. So let's take this off now, and then let's print out what we get from arguments. See, you run that, you see clearly that this arguments right here collects all what we passed in. And so if we don't have the RAM, if we take this off, or if we don't have the GPU, we take that off, you see that this still works. Like, let's take this print out for now. So you see that this still works, as this arguments somehow gathers all this information and stores it in this args variable. So you run that, that's fine. And so now instead of printing out this args, or rather instead of printing out this values we printed out before, we'll use a for loop. We'll say for a in args, we're gonna print out a. So let's run that, and there we go. We have the name, we have SSD size, we have HDD size, and then we have the RAM size. So if we get back to where we had the GPU memory, you see that comes up automatically. If we want to add some other parameter like the color, so we could have say black, run that, you see everything works fine. If we take all this off, see it still works fine. As you may have noticed, we just passed in this name, or we just passed in this arguments without specifying exactly what the signify. And that is why when we did this print right here, even after putting, let's say, 256, when we do the print, we just have this values being printed out, but we don't know exactly what the signify. And so to solve this, we could simply have the SSD memory here. So we define that SSD memory keyword, then we go to the HDD memory. So we have that HDD memory, so 1024, and that's fine. So now let's run this again, and you have this error. Now the reason why you're having this error is because once you have these arguments which are passed with these keywords, then you need to specify the keyword argument with double asterisk before. So here we have the arguments, and then we have the keyword arguments. Now before doing anything here, let's take this off, and then let's print out what we have here. So we'll print out the arguments, and then we shall print out the keyword arguments. You should see that this will come for the arguments, and then this keywords will have all be in this keyword arguments right here. So let's run that, and there we go. We have the arguments, that's MacBook Pro, and then the keyword arguments, SSD memory, HDD memory. Notice how this comes in as a dictionary. And if we just change this, if we have a name here, you see now this arguments empty, while the keyword arguments is made of name, SSD memory, and the HDD memory. And still, just as before, we could always add RAM. So we have 8, for example. Run that, and there we go. We have the name, we have the SSD memory, HDD memory, and then the RAM. So what now we could do is we could simply print this out. So the name is, say, the arguments 0, and then let's have that, and then we print out. So we could take this back, we'll print out. Let's actually use a for loop. So we have for the k in keyword arguments, we're gonna print out the k and the keyword arguments k. So we're gonna print out the key and then the value. So let's have that. Take this off, run that, and there we go. So here we have the name is this, SSD memory this, HDD memory that, and then the RAM that. But now with a big difference that we don't need to specify, or we don't need a fixed number of parameters. We could have a laptop which doesn't even have HDD memory. We run that and it works. And so working with arguments and keyword arguments makes us work more flexibly. Another thing we could do is we could simply have something like, say, params. So we don't necessarily need to have that. We could just say keyword params, or say keyword params, and that's it. Let's just say k params actually. So we have k params and then params. So it's still gonna work the same way. So it doesn't matter how you name that, but generally we name it args and then the keyword args. So we could also have params and keyword params. So key params, yeah, params, key params, and see, it works still fine.